Hello, welcome. Let's try to solve another Leetcode problem. 2311, longest boundary subsequence less than or equal to k. So for this problem, let's just try to understand that. So we are giving a boundary string s, so it's gonna only be 0, 1 because it is a boundary string, and we're also giving an integer k, and we're gonna return the length of the longest subsequence of s that makes up a boundary number less than or equal to k. So let's just take the first example. So for the first example, we can find, because it is not a substring, it is a subsequence, because it is set exactly, it is the subsequence. So for this example, we can find some 0, 0, so this is going to be a subsequence, and then we're going to have a 1, 0. So for the last two string, it's going to be 1, 0. So this is going to be the longest subsequence, so it's going to be 5. So this is why we're going to return 5. So because we cannot find a longer one, maybe you want to add 1, but that's going to be bigger than k. But we need to make sure that number, that the boundary number, going to be less than k, less than or equal to k. So this is the first example. But exactly how can we solve this problem? I'm not sure how you solved it, but for me, I just check the patterns, and I find that I can solve it by using a greedy solution, and then just use a few minutes to finish the coding. But if you see this problem as a DP problem, definitely it's very difficult to solve. You know, the length of the string is going to be 1000, and the boundary string is 0, 1, or maybe you're going to think about it, maybe it's going to be a DP solution, but it's going to be really difficult. So the easiest way is that we're going to see this problem as a greedy solution. So the greedy solution is that because all the numbers is 0 and 1, definitely there are some patterns between these 0 and 1s, because if a number, for example, if for this number, the leading numbers is always 0, and after that it is 1. So it means those zeros doesn't matter. So what matters is only about those 3 ones. Yeah. So this is the idea. So that is why we're gonna use a greedy idea. Now let's just continue. Just to use this example to check why we can solve it by using the greedy idea. So 1, 0 and 1, 0. So our k is 5. Yeah, it means the maximum number can. So it means so for this boundary number, it can never be more than 5. So we're gonna check it from the right to the left. So the first number is going to be 0, so this is okay. So we're going to accumulate it to our result. Currently it is 0. And now we're going to check this next, and the second one. So it is 1. So the result is going to plus 2, because this is a boundary number. So it is okay, because 0 plus 2, it is less than 5. It is okay. Now we're going to continue to check this 0, because it is 0, so it is okay. So plus 0, it is 2, less than 5, it is okay. Now what about we check this one? Because this one is 8, so 8 plus 2 is going to be 10. So if we plus 8, so it's going to be 10. 10 is going to be more than this number 5. This means up to here, it is not possible, right? Yeah, but it means 0, 1, 0, this is possible. But after those 1, it is not possible. But we are going to check the subsequence. It means in between, if there are some zeros, definitely those zeros are also possible, because we can take those zeros out. We're going to take those 4 zeros out, and we still have a 0, 1, 0. So the longest subsequence is going to be 7 in this example. Yeah, so this is the idea. I think now it's enough for us to start the coding. And during the coding, I will explain why we can solve it by using this kind of idea. Because this k is 10 to the power of 9, so basically we just need to check like 30 numbers, and we can get the final result. So the time complexity is going to be O(n), because if we cannot find it, so we need to check all the numbers, so it's going to be 1000 times. Yeah, but if we can find it, it's going to be just 30 times. Yeah, because the maximum number for this k is 10 to the power of 9. It is a small number. Yeah, but what if there's no ones? It can always be zeros. This means we have to check all those zeros, because in between there always be zeros. We have to check that. Yeah. Now I think it's enough for us to start the coding. So first of all, I want to turn the string. I want to reverse the string. Yeah, because if I were to check the first number from the right to the left, I have to check the last one. So I want to check it as the first one, so I want to reverse it. So I'm going to use reversed, and inside it's going to be a list of string. So this is going to be a reversed string, and then I want to join them together. So I want to join the reversed string. Yeah. Or you can use another way. I think it's going to be the same. It always depended on which way you would like. So this is also okay. Maybe this is easier. Let's just print what is s and return a random number, maybe 0. Now let's just check what is the string s after reverse. So it's going to be 0 1 0 1 0 0 1. Now we can calculate the binary number directly from the left to the right. So instead from the right to left, because the left to right is always easier for coding. Yeah. So after reverse, we're gonna check that. So for I say in enumerate the string s, so we're gonna prepare a variable total. So I'm gonna name it as total. So I can accumulate the total. So total gonna plus equal to this number. So I'm gonna turn this string to integer and times 2 to the power of I. Now I want to check the total. So if this total is more than k, this means I need to stop it. So how can I stop? It's going to be I plus string. It's going to be starting from I to the end, and I need to count how many zeros inside. And if I cannot find it, so I'm going to return the string s. And it's not the string s, it is the length of the string s. Yeah. Now let me just run it. As you can see, it works, and let me submit it. Yeah, as you can see, it works and it's pretty fast. And this is going to be an ON solution, and n going to be 1000. Why? Because from here, normally we can check it easily if this binary string is more than k, more than 10 to the power of 9. If it is more than that, definitely we can find it easily. So this is going to be 30 times if we are lucky. So we just need to run the if check 30 times and we can get the solution. But if we are not lucky, we have to check all of them. And then we're going to return the final solution. It's going to be length of the string. It's going to be 1000. And now let's just check it from here. Maybe you're going to think, if this I is 1000, definitely I cannot pass, because 2 to the power of 1000 is going to be a really big number. But that is not possible, because this is the integer c times 2 to the power of I, and this c going to become 0. Because after that, if all those string going to be 0, I need to check 1000 times. So 0 times a big number, it's going to be 0. So in computer, it will not calculate those big numbers, because my first number is 0, so by default it's going to be 0. So this is just an O1 calculation. It is not like ON. That is why for this calculation, even though 2 to the power of I, it may be the situation is this integer c going to become 0, and even though the 2 to the power of I, it may be a big number, 2 to the power of 1000, but this is a 0. So for the number calculation, it's going to be O1 time. We're going to calculate it directly. If this is a 0, we don't need to calculate it like that. Yeah. So that is why it is so fast. So I think that's all about it. Thank you for watching. See you next time.